Okay, and I add my hydrogens. Remember, there's only 4 bonds that can be associated with each carbon. So here's the deal with this carbon right here, right? There's 1 bond here, and then 1, 2, 3 bonds with this carbon. So all the bonding spots on this carbon are occupied. So this doesn't have any hydrogens attached to it. This has the availability for 1 more hydrogen to bond to it. So that is pent-1-ine or pentyne. And so we have 1, 2, 3, 4, 5 carbons, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Okay, and that's actually in your sheet here. So I'm going to fill this one in as well. So again, you can fill this in as we go. So you can see that this is C5, C5H8, and I just did that one, right? There's my pencil. Okay, so this is C5H8. So this is pent-1-ine. You could call it pentyne as well. You don't necessarily need to put the 1, because if you say pentyne, it's understood that the carbon is on carbon number 1. So I skipped over this one, but I'm going to come back to it. Okay. So if I look at the complete structural diagram, I drew that. Okay, so the complete structural diagram shows triple bond, H's. Okay, so that's the complete structural diagram. So remember, the dashes indicate the amount of electrons that are bonded to the carbon. So each one of these counts, right? Octet rule. You need 8 electrons to have a stable outer valence for all of these. So this is 2, 4, 6, 8 electrons that are associated with this carbon, right? So that's why there's only 1 hydrogen there. Condensed structural diagram looks like this. So we have CH, triple bond, C, CH2, CH2, CH3. Okay, and the line structural diagram is this. Okay. Lewis dot diagram looks like this. It's a little bit different. So we have that 1 hydrogen there associated. And then this actually shows, right? So that triple bond shows the electrons, right? So you got to show 3 pairs of electrons between carbon 1 and carbon 2. And that is your Lewis dot diagram. Okay. So you guys saw that. Now you can have branched hydrocarbons as well with alkanes and alkenes, and that's what these are. Okay, so this one right here and this one right here as well. Okay, so I'm going to do those, but if you actually flip over on your sheet, you could also do this one, non-ine. So N, if you go back to your diagram, is 9 carbons. And this is an alkyne. And remember, it's C and 2 times N minus 2. Okay, so if I do the math on that, so the YNE indicates alkyne. So there's 9 carbons. So that means that's 2 times 9 minus 2 for hydrogens. And that is 18 minus 2. Okay, so that's going to be C9H16 is the chemical formula for non-9. Okay? So, let's do this one. Okay, so non-9, C9H16, right? Okay, complete structural diagram is going to look like this. It didn't tell us where the bond was, so I'm just going to put it carbon 1. So there are 9 carbons. 1, 2, 3, 4. Now I don't need to have it in a straight line, right? It just needs to be the longest chain. 1, 2, 3, 4, 6, 7, 8, 9. Okay, so complete, right, shows all the hydrogens. 1, 2, there's 2 hydrogens with this guy, 2 hydrogens here, 2 hydrogens, and then 3 hydrogens. Okay, so that's the complete structural diagram. Condensed structural diagram is going to look like this. CH, triple bond, C. So I just made it, bent it over itself here just so we could have a long chain. Okay, so these are all connected. Line structural diagram is going to look like this. So you can see why I really like using line structural diagrams. They're way simpler. And then you would do the same thing here. So you might want to, I might just have you do this one on your own, but you would, complete this, show 3 pairs of electrons, right? And then you're going to show your carbons, and then you do that all the way through 9. Right, you continue this up until the last carbon, which would show 3 hydrogen bonds. Okay, I'm not going to finish that one, but you can do it on your own. All right, branch, so branched hydrocarbons. So let's look at this one. I'm going to put this one on the board. So whenever you have a double bond or a triple bond, it's always part of the main chain. So that's one thing that you need to take note of. You're not going to have side branches with double and triple bonds. They will always be part of a parent chain. Now the big thing that you need to know about how to name things is we always name closest to where the double and triple bonds are. So the double and triple bonds are more important for naming than the side branches. Or they come first if we're talking about a triage. So this is what you got in your note here. So CH2, you've got in your assignment here. CH2, CH, CH, and then CH3, CH3. Okay, so that's actually the one that's in your assignment. Again, you've got examples that you can do in your textbook as well, but I just want to go through these examples. Okay, so I'm always going to name closest to where the double bond is. So you can see that there's a side branch. Okay, so there's a side branch here, and then there's a double bond. And I always start closest to the double or triple bond. Okay, so then I'm going to make my longest chain. So I have 1, 2, 3, 4 carbons, or 1, 2, 3, 4 carbons. So it doesn't really matter which way I go, but my longest carbon my longest carbon chain is 4. And there's a double bond there. So that's E-N-E. And this is going to be carbon 1, again, because it's closest, this carbon is closest to the double bond. So I have 4 carbons as my parent chain. So this is bute 1-ene, and that's what my parent chain is. And what I've got here is a methyl group. Okay, so then that's on carbon 3. So I name this 3-methyl bute 1-ene. Okay, 3-methyl bute 1-ene, and let's fill this one in as well. So this guy right here, I'm going to name this 3-methyl bute 1-ene. Okay, and let's count up how many carbons there. So there's 5 carbons, so that's C5, 2, 3, 4, plus 3 is 7, plus 3 is 10. So C5H10. Okay. So that's my chemical formula. My complete structural diagram looks like this. Now obviously this is getting a little messy. So maybe when you do this assignment, put it on a separate sheet of paper where there's more space. But you can see there's 3 hydrogens here, 3 hydrogens here. I know that's a little bit hard to see. And line structural diagram is going to look like this. Okay. So I have a double bond. So 1, 2, 3, 4. Okay, 1, 2, 3, 4. And then there's a methyl group on the side. Okay, Lewis dot will look like this. So this is an alkene, right? Not an alkyne. So it's just a double bond. So HH. Okay, that is hard to do when I can't hold on to the paper. And that's your Lewis dot diagram for that. Okay. Here's another one. Okay, so this says 4-ethyl, 5-methyl, 3-heptene. Skina says hi. Hey, dude. Okay. Anyway, 4-ethyl, 5-methyl, 3-heptene. Let's take a look. Okay, so 4-ethyl, 5-methyl. Okay, so 4-ethyl, 5-methyl, and this is going to be hept 3-ene. So that is a double bond. Okay. All right, 4-ethyl, 5-methyl, hept 3-ene. So my parent chain is, I'm going to do this as a line structural diagram. Seven carbons, so 1, 2, 3, 4, 5, 6, 7. And on carbon 3, I'm going to make a double bond. So that is hep3ene. And I have, on carbon 4, there's an ethyl group. So 1, 2, so there's that. And then on carbon 5, there's a methyl group. And then there's that. And that's how you make that. So I'm not going to fill in the rest of that on your chart, but you can, I'm sure you can do that by now. Okay, 4-ethyl. So when you have it, count up all the hydrogens. So you know that there's hydrogens and carbons. So if I look at, right, if I look at the amount of carbons, there's 7 as my parent chain, 8 with the methyl group, 9, 10. So it's C10 something. Right, you know that this is going to have 3 hydrogens, 2 hydrogens, 1, 2, 3, 1 hydrogen, no hydrogens, 1 hydrogen, 2 hydrogens, 3 hydrogens. So add those up. Okay? And that's, like I said, that is in your, that's on your chart. 4-ethyl, 5-methyl, hep3ene. Now I say 3-heptene, but that's not totally correct. On the other side, I don't have any alkynes. So I'm going to show you alkynes. Some branched alkynes. So let's take a look at branched alkynes. All right, so this is 1, 2, 3, 4, 5, 6. So 1, 2, 3. Okay, and so I'm actually going to do this. And I'm going to make a triple bond right here. Okay, so there's quite a few things going on here. So you have an ethyl group, and then I'm going to count up where my carbons are. So this is for sure carbon 1, because there is a triple bond there. So that's always going to be more important than any of these side branches. Okay, when we name. So it's 1 ine something. Okay, I'm just not sure what my parent chain is yet. So when I look at it, it's 1, 2, 3, 4. No. 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is my longest chain. Well, I guess I could go either way. I could go 1, 2, 3, 4, 5. So either way is fine. Actually, you do have to go this way because of the side branch here. Okay, so I have heptine, HEPT. So that's your longest chain here. And then I have a methyl group, an ethyl group, and then this is 1, 2, 3. So that's a propyl group. So I have to name these in alphabetical order. So I have 4-ethyl. Okay. And then I have 2-methyl. And then I have 3-propyl. Okay, so 4-ethyl, 2-methyl, 3-propyl, hept1-ine. So that's a mouthful. Now the reason why we have these different branch hydrocarbons is because when we process fossil fuels, we'll add these extra branches because what it does is stabilize a molecule. So it condenses it more and then makes it more useful for industry. So we call this alkylation. We alkylate these molecules in order to make them more useful for industry. So for example, we'll put benzene rings we'll put benzene rings in octane. So we'll put these benzene branches or onto octane, which is the fuel that we use to fuel your cars, unless you're using diesel. And it gives it a scent, or it stabilizes the molecule. Okay? Makes it burn cleaner and last longer and stuff like that. So we add these branches, and a lot of them exist naturally. So for example, bitumen that we get out of the oil sands. If there's an oil and gas industry after this is all over, because we're in real trouble with that, because it's not worth a lot right now. Bitumen has about 40 different hydrocarbons, and those hydrocarbons all have these dense branches, and that's what makes bitumen such a thick fuel. It's a very heavy hydrocarbon, and so it sinks, does stuff like that if there's a spill. And it needs to be processed in a heavy oil refinery. Anyway, I'll give you one more. So 1, 2, 3, 4, 5. Let's look at this one. Okay. So, so this is 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. So again, this is the double and triple bond, and these are the side branches. So I number closest to where the side, not where the side branches are, to where the double or triple bond is. So this is 5, and this is on carbon 2. So this is pent 2-ine. So it is an alkyne, and the triple bond is on carbon 2. And I have 1, 2 different groups. So this is a single carbon and a single carbon. So this is a methyl group, and this is a methyl group. And these are both on carbon 4. So I have to name this. So what I have to do is name where the location of each is. So I have 4, 4. I can't just put 4, because that's only going to indicate that there's 1. 4, 4, dimethyl. So there's 2 methyl groups. So not only do I have to indicate where they exist, okay, they're on carbon 4. I have to indicate where they exist. I also need to give the amount and the location of the bond. And that's what this does. Okay, so 4, 4, dimethyl, pent 2-ine. Okay, so the naming rules for alkenes and alkynes are the same as alkanes. Okay. And we'll leave it at that for today. I'll put a few more examples up in a few days here. We are going to name carboxylic acids and esters and halogenated hydrocarbons as well. But I'll do a few more examples of these in my next lecture. We're going to name alcohols as well, so you'll have a few assignments to do with that. Anyway, that is the start of organic chemistry for today. We will chat with you later, Science 30. Bye now.